So, hello everyone who has already joined. I am seeing 17 participants so far, and a minute has passed. So, I would say we will simply start for now. First of all, hi, my name is Tim Schulze. I am the product manager for 3D at mediCAD, and I will be hosting today's webinar. So, as a brief overview of what we will do today, first of all, we will take a look at the newest features in general. We will be doing so, checking out the AO osteotomy and what is new about it on 2 cases. We will also take a look at the torsion module, so do torsional measurements and maybe also do, for example, patellofemoral measurements, primarily maybe TTTG. That's the plan for today. So I would say we jump right into it. Also at the end, everyone can ask questions also in between. I will be trying to check the chat from time to time. Right. So the first case we will look at is this case here. So we have an overview for the images here. In this case, locally. In the hospital, it would be via PACS, of course. But for this purpose, we have demo images here. So we click on the image, and then we can load the image into the software. And in this case, already start the planning. In this case, we don't have a scaling sphere, so we can simply manually scale, in this case, via line. So for example, we go from 90 to 80, and then simply select 100 millimeters, 10 centimeters, and scale the image. Let's reselect the orientation. In this case, it's a simple AP view, and we continue. In this case, the software already does the segmentation automatically, so it detects the landmarks, and we don't have to do this, and we don't have to click this button here manually. Now we can select the relevant body size. In this side, in this case, we can select the left side, simply click on the module. In this case, we want the AO approved AO osteotomy for deformity correction, and we simply click on it. And as you can see, the software has already detected all the relevant landmarks. What we can do now and what we recommend and should always be done is to check the landmarks. So we can click here on this overview and one click and then simply readjust so that it fits the landmarks. We do this for the other parts of the leg as well. Careful not to include osteotophytes and simply go through the long leg like this. After we have done this, we can then move on by accepting and continuing. So in this case, if we click A, we get the full image again. On the left side, we can now see what the software has detected and what it recommends as well. So we have a varus deformity, it's coming from the tibia, and the software is recommending us to do a medial opening wedge HDO. So we can simply confirm in this case, and now, for example, adjust the osteotomy line. So then we can also change the correction objective. So for now, it's 1 degree valgus. We can also change this to 1 or 1.5, whatever you prefer. Or we could also go by weight bearing. So in this case, it would be Fujisawa. If we are satisfied with how we put the osteotomy line and the correction objective, we can simply perform the cut, which the software will do automatically. And now the software has performed the osteotomy for us. We can see the values here are green now, basically traffic light system with increasing yellow, red values based on standard deviation. In case you would ever want to also adjust your osteotomy, you could simply hold your left mouse button and do it like this. Just drag and do it like this. So that was the first image. What we can also do is now, for a second example, we simply go back to the main button select one of the most recent folders, in this case, this planning, and this image. We load it into the software again. This image does have a scaling sphere, so we can make use of this, of the automatic scaling. Simply scale it, select the orientation again, continue. The segmentation will be performed automatically again, selecting the body side and opening the AO Osteotomy module again. So once again, before we proceed, we will need to check the landmarks and adjust them if necessary. Just going through the entire long leg axis, like this. So step by step. And once again, as soon as we are satisfied with the results, we can simply click accept and continue. So once again, we have the overview here. We also have it on the right side. For now, the planning values are the same as the anatomical measurements, so they don't change for now because we haven't corrected anything yet. But in this case now, we could simply confirm. And again, we have a different value here after adjusting the osteotomy line. So if we perform the cut, we are also warned of high GLCA. Anything above 3 degrees will be displayed as red here. So it's just to be aware of overcorrection. And also the software gives us a warning that this is possible. And we could also choose to do a second cut, for example. So in this case, we selected no, so we're only doing a single cut. But if we, for example, delete this and, for example, change it to 1.5 and just adjust the osteotomy line again, perform the cut, we're asked again. And in this case, the software asks us, hey, we cannot reach the goal, the target. Do you want to proceed with a double level osteotomy? So we say, yes, sure, we want that. And then the software also gives us the option to put the lateral closing wedge DFO osteotomy line, which we can also adjust in place and then perform the cut. And now we have corrected the target and reached the target. As you can see here, 1.49. Also, we can simulate a GLCA correction. So for example, if we go down, we say we want to correct it to 2 degrees and click OK, then the software will do this. It's just important to be aware that we then would need to adjust the osteotomies accordingly, as you can see here. So we could just adjust them as well again, slightly to match the target value. Exactly. That's it for the AO osteotomy. The newest features are basically that we can also correct the JLCA, simulate, and also correct by Fujisawa. Once again, we can go to new planning. We do not want to save it this time. We can just click no and select a different image now. In this case, we have a CT that can be stitched. So we have a hip, knee, and ankle joint. And if we select these 3 CTs, then the software already knows, okay, they can be stitched. So do we want to merge them? Yes, we do. So we wait for the software to automatically do this. And after it has done this, it asks us if we want to proceed with the planning, which we also do. We click yes again. So now we are in the overview for the 3D. So we have the AP view, the actual view on the sagittal plane here, and also a reconstructed 3D module here. For the new features, we have, after selecting the body side, this torsion module here. So what we can simply do is we go inside of it, and then we can quite easily measure the torsion. On the left side, you always have a visual guide with the steps that are supposed to be done, short explanation, also in text, and then we can just perform the measurements, jumping through the slides. In this case, it would be according to Weidlich, so a German way to measure the torsion. So also this is supposed to jump to the right slide, but sometimes you do have to make minor adjustments. You will always be the best judge of what landmarks you want to measure. We have measured the femoral torsion now, and as you can see, we have increased internal torsion here. How long did it take? Not even a minute with explanation. If we do the same for the tibia now, scroll through the slices a bit and grab the points that are relevant for the torsion measurement here. So we have now two values here, indicated in the traffic light system again, and also a nice overview here about the femoral and tibial torsion. In addition, we also have the knee version for the distal femoral and for the proximal tibial version. This could also be a good indicator if there's any tension. And yes, of course, you know better how to use these values at the end of the day. This would be it for torsion. What we could also do now is we go back to the main menu. And for example, in the patellofemoral measurements, we could, for example, add the TTTG. So as you can see, we have already grabbed the femoral condyles. So we only need to grab the trochlear groove now. So we scroll down. Maybe we can zoom in a bit to see it better. And grab the first point. Scroll down to the tuberositas. And grab the relevant point here as well. And then we can see here on the right side already the TTTG. And what we could do now, if we were to simply go through the deformity correction, for example, perform a plan for the long leg axis. So just going through the relevant measurements in the long leg. So we can start with the hip joint center. And the tip of the quadrate trochanter, for example. And simply go through all of these measurements. But what we could also do, which is also a new feature for the 2.7, is we can, for example, if we were to delete these measurements again, just to have a clean slate, so to speak, we can also perform here segmentation. And what this does is it automatically detects all of the landmarks. And then we can basically do automatic measurements. So it might take up to a minute, perhaps, for the segmentation to be performed. It also asks us for metal artifact reduction. And then it will start performing the segmentation, detecting the relevant landmarks, which you can later see here on the left side, and which we can also, if desired, adjust. But for this case, we could simply accept them and move on. And then we could, for example, perform a quick plan with the measurements, which we can always also adjust. So these measurements are automatic, but we always have the option to later adjust them manually, just in case they are not as accurate as we want, or if they are grabbing a different landmark than what we want. So it is always possible, and I think very necessary, to be able to allow the user to manually adjust these measurements. If we give it a few more seconds, the segmentation should be through. And at this case, we could either check the landmarks that we have confirmed, or in this case, we will just accept them and then move on to the next step. So as you can see, we have detected many, many landmarks. But for this case, we can just accept and continue. And if we go to a workflow now, you will see that we have the option here, auto. So this was not available before, but since we have allowed the software to run the segmentation first, it allows us now to do auto measurements. And of course, with time and more images we allow the AI to train, it will only get better at measuring all of these landmarks. So if we just choose the values here. So, or we could also, again, just do this manually, but it's also possible to do it automatically here. So on the right side, we have now the values that the software has detected. And if we are happy with them, we can, for example, proceed with the osteotomy planning. For example, since we also have torsional measurements, we could, for example, perform a rotational osteotomy. If we check the values, they are, as said, they are somewhat pathological according to the values here. If you hover over it, you can also see what we have defined as the norm values. So you could, for example, just put the cut here, and then, for example, for mechanical, and then just for demonstration purposes, select maybe 15 degrees. You can also see how the varus will change here, and how the other values will change. And for example, if we go external now, you can see that the femoral rotation will change from 43 to 29 roughly. So if we, for example, now perform the cut, we would then see how the software adjusts the leg. And then we have, most importantly, the corrected values here. And yeah, if we do not do an osteotomy, but for example, a total knee replacement, then we could go to the long leg TKA module and, for example, also do TKA alignment measurements or perform the resection for the femoral and tibia and then insert implants. For now, this has basically covered all of the newest features. So that would be it from my side for now. And I'm open to questions now. I can see candidate can you demonstrate torsion measurements? Neither. Of course. So for example, if we go to Schneider now, we can delete the Weidlich, for example, first. And here. So for once, just by hovering over it, you are given the option to perform, to watch a tutorial video, which is available. And also on the right side, you can probably see there's also a tutorial video. So in addition to the manual, there's always the option to have your to have a guidance here by the software. So for example, if we start by grabbing the femoral neck, the diameter, so we have now here the diameter, and then perform the epicondyles, the measurements for the epicondyles. We have now the torsion for Schneider here. In this case, we have these somewhat different, of course, norm values, but nonetheless, in this case, would be pathological. I hope this could answer the question. Thank you. Yeah, you're welcome. All right. Any other questions? In case after the webinar is over, some questions arise out of curiosity, maybe we already have users of mediCAD 3D knee here in the webinar, do feel free to approach me. I'm always open to chat about the knee, so feel free to approach me. Yes, let me unmute you.
Yes, hello. Hi.
Hello.
So I would like to, I have a question. It's like in the clinic where I'm working, it's not possible to have like the whole leg view after the knee end prosthetic. So we are having really a big problem to calculate the post-operative axis of the knee. Do you have any helpful tip for that problem?
So after you perform the long leg TKA in the software, what exactly happens?
No, we like, I would say a patient comes to a knee implantation. So we all the X-rays that's required, which includes Ganzbeinaufnahme. I'm sorry that I have to use the German word because.
Don't worry.
So, okay, so the problem is with our radiation exposure commission, we are not allowed to do post-operative Ganzbeinaufnahme. But we are still certified, so we have to measure the post-operative axis of the knee. And we cannot do that because we don't have a post-operative Ganzbeinaufnahme.
So basically, you are probably referring to trying to match a post-op partial knee to a pre-op long leg, the entire thing correctly. Okay. Exactly. Yes, that's a good point. So far, I can't say anything too clear about this, but we are certainly thinking about that since we have heard a lot of it from a lot of different users. Yeah.
Okay. So it's still not solved, that problem.
No, so far it is not available. No.
Okay. Thank you.
Yes, sure.
Okay.
Okay. In case there are no other questions, I think this concludes the webinar. Thank you very much for your attention and have a great evening. Bye.